So we're going to be talking more about functions and the graphs of functions, but first we're going to look at piecewise functions. So recall that a piecewise function is defined by two or more equations and each one of those equations only works over a specified domain. So for instance, one of the specified domains we have here is x is less than -1, and then we would use this equation. One of the specified domains we have is x is greater than or equal to 1, and then we would use this equation. So when you look at a value of f of -4, you'll notice right away that -4 would fall into the blue domain, less than -1. So we're going to plug this into this equation, and then we'll find that f of -4 is equal to 12 minus 5 is equal to 7. Let's take a look at the second one, f of 3. F of 3 is in the yellow domain, values that are greater than or equal to -1. So we'll plug 3 in here, and of course we're going to get 10. Okay, let's go down and look at the next ones. Again, we'll define the top one as the blue function, x is less than 0, and the bottom one as the yellow function, 2x plus 1. So since -5 is less than 0, he's going to fall into the blue function. It's 5 times -5 plus 4. That's going to be -21. F of 0, now if you look at this, one of these is greater than 0 and one of these is less than or equal to 0. So f of 0 actually falls in this yellow category. That's going to be 2 times 0 plus 7, and that's going to be equal to 7. So now let's take a look at graphing piecewise functions. So notice that this value is the same. That's the value that splits the domain into two half planes. So I'm going to plot that. Then on this side over here, I'm going to graph the function 2x plus 1. Remember that this is open circle and this is closed circle. So since the function that's less than does not include the boundary line, I'm going to put an open circle there. This guy right here is for values that are greater than or equal to 1. That's going to be on the right-hand side. That's going to be here. I'm going to do closed circle. And that's my graph. Okay, let's take a look at number 4. Same thing. I'm going to start by looking for the boundary line. This boundary line is at -1. I'm going to put the less than function, this guy, on the left over here. And this guy actually includes the boundary line, so he's going to be closed circle, whereas this guy over here is going to be open circle because this does not include the boundary line. So let's start with the one on the left. This is going to be y equals x. That's this graph. Then let's look at the one on the right of the boundary line. That's over here. That's going to be y equals minus x plus 4. And go all the way up against the boundary line and then open circle. Okay, so now let's talk about various characteristics for functions. Increasing functions. The basic rule for increasing functions is that as x is increasing, okay, in other words, as the input is increasing, the output, f of x, is also increasing. For a decreasing function, we would say that as x is increasing, f of x is decreasing. And lastly, for a constant function, we would say as x is increasing, f of x is constant, right? In other words, it's neither increasing nor decreasing, it's staying the same value. So these, you might notice that every time we talk about x as increasing, and then the function is determined by what the output is doing. So increasing, decreasing, and constant are all saying what the function's doing, not what the input is doing. So let's take a look at a specific example by looking at a graph. So determine the intervals over which this function is increasing. So remember, increasing means that as x is getting bigger, the function's getting bigger. Right? So as x is increasing, that means I'm looking this direction. As I look from left to right, here's a place where the graph is increasing. Right? So that's x is going to be from -2, and then here's where it stops increasing, right here, to -1. And then it increases again over here from 3, oops, let's write these with open brackets. -2 to -1 and 3 to 4. Okay, let's look this time where the graph is decreasing. So you can see there's only one area here where it's decreasing, and that's from the values x is 1 all the way over to the value x is 3. And then here we can see this is where the graph is constant. And the graph is constant for the x values -1 to +1. And remember, all these are describing x. Okay? They're all describing x. Let's look at a couple other characteristics of the graph. Now we're going to talk about something called a relative minimum. A relative minimum is where the graph has the smallest value over some interval. So, where would the relative minimum be? Well, in this case, there's a relative minimum here, and there's a relative minimum here. So I would say that the relative minimum occurs at -2 and is equal to 0. And I would say the other relative minimum occurs at +2 and is also equal to 0. Let's talk about relative maximums. Alright, so this guy's a relative maximum because he's the highest point in this little neighborhood that I've shown, okay, between those two little blue lines. He's not the absolute maximum because you can see over here that the graph is actually going to go way higher over here, but he's just the highest point in a given area. Kind of like how Mount Diablo is the highest mountain around us, but it's certainly not Mount Everest. So a relative maximum is going to be where our function takes on the largest value over some interval AB. And I would say here my relative maximum happens at 0 and is equal to 3. So notice that I'm putting the x value here. That's the value where it happens. And then I'm putting the value of y here, and that's the what of what is the maximum. Okay, let's take a look at this guy. Describe the intervals over which the function is increasing. Notice that the function is increasing from here to here, and then again from here to here. So remember, we're going to describe those intervals in terms of x. That's going to be from -3 all the way to 0. And then it's going to increase again starting here. and then it never stops increasing, so from 3 to infinity. Let's use this graph to talk about where the graph is decreasing. So here it's decreasing, and here it's decreasing. Okay, over here we would say the graph is decreasing from negative infinity all the way until we reach negative 3, and then it decreases again starting at 0 until we reach 3. This graph doesn't have any places where we have a constant or a flat area, but we can look at this graph and state the relative maximum. We can see the relative maximum here. It occurs at 0, and it's equal to 3. And we can see that this graph has relative minimums here and here. And we could say that those occur at negative 3. The relative minimum is negative 3. And at positive 3, the relative minimum seems to be at about negative 2.5. Last thing we're going to talk about is even and odd functions. For even functions, it doesn't matter if the input is x or negative x. They're going to be equal to each other. Okay? So, for an even function, the output does not change when the sign of the input changes. So you'll notice here in this picture that I had the same output when I plugged in a negative x as I had when I plugged in a positive x. So remember when we talked about plugging in negative x, this is where it's important to plug in negative x correctly, because this is our test for an even function. So the first thing I'm going to do is I'm going to plug in negative x, and then I'm going to simplify this expression. So this simplifies to x to the 4th minus 2x squared. Now because this expression, the one I started with, and this expression, the one I got when I plugged in negative x, are equal to each other, I can say for certain that g of x is even. Okay, let's talk about negative x, odd functions. Notice this time when I plug in negative x, I get a negative value, and when I plug in positive x, I get a positive value. In other words, if you plug in negative x, instead of getting f of x, you get the opposite sign, f of negative x. So let's try it for this example number 9. Again, I'm going to use my test is to plug in negative x. I get negative x quantity cubed minus 6 times negative x. And this is negative x cubed plus 6x. This time you'll notice that while this sign was positive, this one's now negative. And while this sign was negative, this sign's now positive. Okay? So what we notice is that everything now has opposite signs. And that's going to make this guy odd. Okay, so let's take a look at problems 10a through 10c and test to see if they're even or odd. Remember, the test is to plug in negative x. This becomes negative x cubed plus 5x. This went from positive to negative. This went from negative to positive. Because the signs changed for every term, this guy's odd. Let's plug in negative x here. I get 4x squared plus x, plus x to the 4th. This was positive, this was positive, this was positive, this was positive. Because none of the signs changed, this guy is even. Try 10c and you'll notice that in the first case the sign changes, but in the second term the sign does not change. And that makes this one neither.